Hi all, let's take a look at the law of cosines. This is one of my favorite trigonometric applications just because it's going to be used continuously. Law of cosines is actually ends up being a little more helpful than the law of sines. So the law of cosines that we're going to be looking at in this section, as you can see here in our objectives, we'll be using the law of cosines to solve oblique triangles. Remember, oblique triangles is just any triangle that doesn't have a right angle. And in fact, even if it does have a right angle, it still, the law of cosines can be used. We will solve applied problems using the law of cosines, and then a few problems at the end of the section. We'll be looking at areas of triangles by using Heron's formula, using the semi-perimeter of a triangle to determine its area. So when we're solving oblique triangles with the method of the law of cosines, the two types of triangles that we're going to be looking at are what we call a side angle side and side side side. Side angle side is when you know the angle between two sides. It can be any two sides. If you know the angle between it, law of cosines can help out. What if you don't know any angles? As long as you know all three sides, you can find all of the angles using law of cosines. So our law of cosines formula, I have here solved for the square of each side. And the reason I like these formulas is because it shows you the Pythagorean theorem. It's really just an application of law of cosines. We say a squared plus b squared is equal to c squared is your Pythagorean theorem. Well, you look at this and you see c squared is equal to a squared plus b squared, and you say, well, but the rest of that isn't the Pythagorean theorem. It really is. The Pythagorean theorem is a subset of the law of cosines. We know that if c is the hypotenuse, then the angle opposite it would be a 90-degree angle. And you also know that, hey, well, then the cosine of that 90-degree angle would be 0, which makes this entire last term all be 0. And so you say, then the Pythagorean theorem is merely a subset of the law of cosines, where the last portion cancels out because it's being multiplied by the cosine of a 90-degree angle, which is 0, makes that whole thing 0, and we still have our law of cosines formula. Now, what I would like you to remember, a lot of people look at this and say, well, do I have to memorize all three? Well, not really. All you have to remember is that any side squared of a triangle is equal to the sum of the other two sides squared minus twice the other two terms product times the cosine of the angle opposite the side you're looking for. So if you notice here b squared, well, it's equal to a squared plus c squared minus 2ac cosine b. Normally we'd solve it for c squared and say, well, c squared is equal to a squared plus b squared minus 2ab cosine c. Easy to find a, you just say, well, a squared, it's equal to the sum of the other two legs squared, b squared plus c squared, minus twice their product, minus 2bc, times the cosine of the angle opposite the side you're looking for. That's why we have the cosine of a there. So these are easy formulas to memorize. And yes, we do need to know them. So if we're solving a case where we have the angle between two sides given, so we'd call it the side angle side scenario. Well, the first thing you'll do is you'll use the law of cosines to find the side opposite the given angle. So it'll be the third side. Once you've found that third side, you're going to have a ratio that you can set up where you can say, well, that side divided by the sine of the angle that we know is opposite it. So at that point, we can use the law of sines to find the angle opposite the shorter of the two given sides. And please notice, you always want to find the shorter angle after you find the last side. And then at that point, it's easy to find the third angle by just subtracting the two angles you know from 180 degrees. Let's look at an example of that. So let's say in this case, I give you angle A is a 120-degree angle, and then you're told that side B is 7, side C is 8. You can see, well, yeah, this is the law of cosines because we know the angle that's in between two sides. So it should be easy to find the other side. So you can say, well, yeah, the other side A, I can use the formula. A squared is going to equal B squared plus C squared minus 2BC times the cosine of 120. That's where all of that came from, just plugging that into my basic formula. When I do that, I see that a squared is going to equal 49 plus 64, and then minus 112. And I know that the cosine of 120 degrees is a negative 1/2. Whenever I multiply and add this together, I get a squared is 169. So a is the square root of 169, 13. Now that also makes sense because I can see that a is the largest angle in the triangle. So a should be the longest side, certainly is, 13 units. Now, once I find a, I can use the law of sines. I can say, well, I could either find angle B or angle C, but now following the method of the law of sines, it's better if you find the smaller angle. So I'm going to find angle B on the next page. I'll say the sine of B divided by 7 would equal the sine of 120 over A. Notice now, next page, we do that. So I'll use the law of sines to find the angle opposite the shorter of the two given sides. So I'm finding angle B. And you can see here, I'll get that the sine of B is equal to, whenever you do your cross multiplication and then divide by A, you'll get that the sine of B is equal to B sine A divided by A. At that point, you can just plug everything in. We'll get B, which is our 7 times the sine of 120. Which that's going to give us the square root of 2 over 2 divided by 13. When I plug that into my calculator, I get that the sine is approximately 0.4663. I go to my calculator, I take the inverse sine, and we'll get a 28-degree angle approximately, and they always want us to round to the nearest angle. It's not exactly 28 degrees, but it rounds to 28 degrees. Now, you might think, well, okay, that's an acute angle. Could it be an obtuse angle? Of course not. We know it's the smallest angle in the triangle, so it has to be the acute angle. And plus, we already have the obtuse angle as angle A. So once we get that angle B is 28 degrees, it's easy to see what our other angle is. You could just say it's going to be 180 minus 120 minus 28. So that's 180 minus 148. And we'll get our 32 for the remaining angle C. And at the end, you should have all angles and all sides when you finish these problems. Now, the other scenario you're going to see with this law of cosines is when we have all three sides given. Usually students don't like this method as much as the other. The other one's a little bit more straightforward. When we have all sides given and you're left trying to find the angles, the most important thing is your first step. The first step, you have to find the largest angle first. So we're going to use the law of cosines to find the angle opposite the longest side. Now, unlike with the law of sines, we're not going to be left guessing about, well, is this the obscure case? Could there be one solution, two solutions? We don't have to worry about anything like that, because when I use law of cosines and I take the inverse cosine, please remember the inverse cosine is defined from 0 all the way to pi, from 0 to 180 degrees. So if it needs to be an obtuse angle larger than 90 degrees in order for the triangle, that's fine. My law of cosines will give me that. After you use the law of cosines to find one angle, then it's easier to use the law of sines to find the remaining ones. So you can find either one of the other two remaining acute angles with the law of sines. And then after you find one of those, you can just subtract from 180 to get the third. Okay, so if I give you a triangle that has sides of 5, 8, and 10 here. So we see that side B is my longest side. It's a length of 10 units. So I know that angle B is my largest angle. There is no question then. I need to solve for angle B first using my side, side, side law of cosines formula. So I can say, okay, my formula for B is B squared is equal to A squared plus C squared minus 2AC cosine of angle B. Now, I can move this minus 2AC cosine B to the left, and it would become positive. I can move the b squared to the right and becomes negative. So I get this equation. Now I can isolate the cosine of b by itself by just saying, well, I just need to divide 2ac on both sides. So I get the cosine of b is a squared plus c squared minus b squared, all divided by 2ac. Now, at this point, I should be able to plug in everything I need and be able to solve for angle b. So the cosine of b is going to equal a squared. Well, that's my 5 squared plus c squared. My a squared is my 8 squared here. I apologize. It's the side opposite a. So a squared is your 8 squared plus c squared. That's your 5 squared. And then minus b squared, so minus 10 squared, all divided by 2 times a times c, 2 times 8 times 5. I'll plug this in. Your numerator is going to be 64 plus 25 minus 100. That gives me a negative 11. Your denominator is just going to be 10 times 8 for 80. So I get a negative 11 over 80. Now, that's what the cosine of b is equal to. The second I get that negative answer, I know, hey, this is going to be an answer greater than 90 degrees because the cosine is always positive between 0 and 90, but the cosine takes on negative x components on the unit circle between 90 degrees and 180 degrees. So I knew as soon as I got that cosine of b was negative 11 over 180, I knew that b was an obtuse angle. So I find that angle by just saying, well, take the inverse cosine of negative 11 over 80 in order to solve for b. And when I did that, my calculator rounded to the nearest degree was 98 degrees. Now, again, that makes sense. If you think of 98 degrees on the unit circle, the x component's going to be slightly negative. This is negative 11 over 80. You can say, yep, that's at 98 degrees. And again, every single time the cosine is negative, b is going to be an obtuse angle. If the cosine of b is positive, b is going to be an acute angle. Now, for the next step in this problem, you say, all right, once you found that angle, b up here is 98 degrees. Now you can use what we know as far as our law of sines. You can say, well, if I know that 10 divided by the sine of 98 degrees is one expression, that should equal a over the sine of a. Well, a is 8, and the sine of a I could look for. Well, when I'm looking for that, I could just say, well, I could go ahead here and cross multiply and say I would get b sine a is equal to a sine b, which means the sine of a is equal to is equal to a sine b divided by side b. That's what I have right here. At that point, plug in what you know. Your a in this case is 8. The sine of b, that's what we found, 98 degrees divided by 10. When I do this, I'm getting that the sine of a is approximately 0.7922. So this is asking you, at what point is the y value on your unit circle 0.7922? We know it can't be obtuse because because b is my obtuse angle. So this has to be an acute angle. Inverse sine will be just fine for it. When I find the inverse sine of 0.7922 on my calculator, rounded to the nearest degree, it's 52 degrees. So then at that point, I know that the first angle B I found was 98 degrees. This angle's 52 degrees. You add those two together, you get 150 degrees. So we know our remaining angle C has to be 30 degrees. That's what I found here. We know angle C has to be 180 minus the two angles you've already found. When you do that, you'll get that that angle is approximately 30. Now, again, these are rounded to the nearest degree, which is what both my lab and your book will want. Now, for the next types of problems that you'll see, the applications in this section, they really don't get too bad. Let's say we have a problem in which you have two airplanes leaving an airport at the same time. I have my airport down here as point B. Now it says one is going to fly north at 400 miles per hour. So that's straight up 400 miles per hour. And then the other airplane flies on a bearing of 75 degrees east of north. Well, that means this angle right here, it's 75 degrees east of north. So this angle right here is 75. And we know that they're going at 350 miles per hour. we're asked how far apart the airplanes will be after 2 hours. So I just did a little simple distance equals rate times time. This one was going north at a rate of 400 miles per hour for 2 hours. So the vertical distance here is 800. This diagonal distance at the direction of 75 degrees east of north, we know it's just 350 times 2. That's a distance of 700. So anytime you know two sides of a triangle and the angle between them, it's easy to find the other side. The third side of this triangle is going to be the distance the two planes are away from each other after 2 hours. So no problem. We can say in this case, the way I have it labeled, if this is angle B, this would be side B. We know B squared is equal to A squared plus C squared minus 2AB cosine of the angle B here, which we know. So I can find that distance. I'll call it B squared. It's going to equal 700 squared plus 800 squared minus 2 times the product of 700 times 800 times the cosine of the angle between them, 75 degrees. When I solved for B squared, I had 840,122.67. And of course, don't worry about how large that is. We're taking the square root of it because we need B, and B is approximately, and whenever we do this, we're going to get approximately 917 miles apart. If this plane goes 800 north and this plane goes 700 miles in a direction of 75 degrees east of north, then the distance between them, 917 miles. Now, often in your homework, you'll need any side of a triangle to a 1/10 of a decimal place. I believe I just rounded to the nearest mile per hour in this case. Now, the last thing that you'll see in this section is your area of triangle formulas, and this is going to be very easy. Heron's formula, it's not important enough for me to make you memorize, but it's super easy to memorize. The area, it says, where S is equal to half of the perimeter, so you just say, well, you just add all the sides together and divide by 2, and that's what S is in this problem. It's saying the area is equal to the square root of half of the perimeter minus the product of half of the perimeter being subtracted by each side of the triangle. So you have S times S minus A times S minus B times S minus C, all of those products under a square root for the area of your triangle. Now, this also, as a corollary to this area formula, you could just say, well, then this means that any side of a triangle has to be less than 1/2 its perimeter. Because if it's not less than 1/2 of its perimeter, you're not going to get a positive value for the area of the triangle. So you can say any side of a triangle must be less than half of its perimeter. Now, using Heron's formula to find the area of a triangle here with me real quickly. What if I say you have a triangle that has sides of 6 meters, 16 meters, and 18 meters? First thing you do is you just say, well, if I need to know the area of it, first I find the semi-perimeter, which is just your perimeter divided by 2. Well, the perimeter would be 6 plus 16 plus 18. We know that that's going to be 6 plus 16 is 22 plus 18 is 40. You take that 40 divided by 2, you get a 20. So the semi-perimeter, half the perimeter is 20. That means our area is going to be the square root of 20 times 20 minus each of the sides. So 20 minus 16, or sorry, 20 minus 6, 20 minus 16, and 20 minus 18. You're going to have the square root of 20 times 14 times 4 times 2. Whenever you multiply all of that out, you'll get the square root of 2240, which that square root is approximately 47 units squared. Now, in this case, I shouldn't say units because we know the units, it's meters. So this is going to be 47 square meters or 47 meters squared. All right, guys, that finishes up everything that you need to know in this law of cosines section. The main point of emphasis is using that law of cosines with a side angle side and the side problem. So please make sure you're comfortable with that. I'm much more interested in that than this Heron's formula here at the end of it. Please let me know if you have any questions. I'll be glad to help.